Hi everyone, my name is Philip and my presentation today is on alternative energy. Now let's dive right in and discuss what alternative energy actually is. Alternative energy uses renewable resources to generate electricity. Renewable resources are, for example, solar, wind, tidal power, or hydroelectricity, geothermal power. And unfortunately today, as you can see in this little pie chart, most of today's global output of electricity is created through non-renewable resources, about 85%. And these non-renewable resources are, for example, petroleum, coal, dry and natural gas, which are all fossil fuels. Now, nuclear electricity is also a part of our non-renewable resources, and you will see why in a bit. Now, so countries So most countries in the world have decided to target that by 2030 they'll use between 20 to 50% of their electricity will come from renewable resources. This varies from country to country and really depends on their goals. Now, what is interesting though is that Iceland already uses 100% renewable energy. Iceland made the switch in the 1970s to hydroelectricity and geothermal power because they have a lot of rivers and they have a lot of volcanic activity, which helps geothermal activity. So it made sense for them to make the switch in the 1970s, but they did not do so out of environmental concern, but they mostly did so that it can be self-sufficient since it's such an isolated place in the world. And at the time, oil prices were extremely expensive, so it just made sense for Iceland to find a resource that they have that they can use for electricity. Now, before we continue with types of alternative energy, I want to mention that most energy sources in the world currently use the same principle, whether they're renewable or non-renewable, of kinetic potential energy. So basically, anyways, whether it's burning coal or whether it's nuclear energy or wind power or hydroelectricity, most of them essentially, the goal is to spin a turbine and a generator transforms that into electricity. Now, whether if you're burning coal, that creates heat and steam, which is in turn used to drive a turbine that generates electricity. With nuclear power, it's almost the same thing, except you're splitting atoms and then creating steam and spinning a turbine. But with hydropower, all you're doing is taking the kinetic energy of water and essentially spinning a turbine with it when the generator transforms that into electricity. But we'll get to hydroelectricity soon. There are many types of alternative energy I have already mentioned, but let's talk a bit about all of these. So basically they all require some sort of natural phenomenon, such as wind, for example, direct sunlight for solar energy, for solar panels, photovoltaic cells which transform it into electricity, and geothermal energy relies on magma, ground steam to spin a turbine, and so on and so on. Now, what about nuclear? I said I would touch on this in a bit, and so here I am. Nuclear energy is, in and of itself, is a renewable resource. But the way we generate nuclear energy, which is using uranium is not renewable, and it creates a lot of radioactive waste, which is by no means good for the environment, and it is extremely hard to store safely so that it doesn't have a harmful effect to humans, animals, or the environment itself. Currently, the radioactive waste is stored underground, and there are certain parameters that have to be met between how thick the cement walls are, and but there's still possibility of leakage, and it's still not entirely shielded. So there are many zones in the world close to nuclear power plants which are called radioactive zones, and you can't enter them because of the waste that is stored underground. Now, this brings us to issue number one, hydroelectric power. I've already touched on this somewhat, but basically hydroelectric power uses water to produce energy. The simplest way to explain this is that hydroelectricity is created by converting the gravitational potential or kinetic energy into electricity. Now, the way this is done is through a turbine that spins and a transformer and a generator that create it into electricity. Now you can see this little chart, this little picture I have here, this little GIF that shows basically a dam on a river. The water flows through the dam And then the gravitational potential energy and the kinetic energy of that water basically spin a turbine just like old wheel wells used to do, and a generator produces the electricity. Now, there are many advantages to hydroelectricity, but there are also some disadvantages. The reason most of the world renewable energy output is through hydroelectricity is because if you build a dam the right size, you can have a massive energy output, but it does come at a cost, and it is expensive to build these dams. But on the plus side, it is a renewable resource, it has almost no emissions, and it is extremely safe for the environment, for communities surrounding the dam. But that it could have environmental consequences for aquatic species, for example, fish. Migration patterns of fish become blocked off by this dam in the way, basically, if they're going downstream or upstream. Now, a lot of dams have tried to combat this by building fish elevators that allow fish to migrate freely, but it still isn't ideal for these migratory fish species. Now, it is very reliable, unlike sun, the wind, or other energies, because, for example, on a cloudy day, you're not going to have the same amount of solar output as you would have on a clear day. And in the winter, you're going to have even less solar output than you do in the summer, because the days are shorter, you get less sunlight. And the same thing goes for wind. If it's a windless day, the turbine is just not going to be spinning, and you're not going to be generating any electricity. Now, potential energy is already stored. Now, what I mean by that is, it's a bit confusing, but essentially coal and oil, right, for example, or gas, right, can be used year-round, and no matter what the situation on Earth is. But with for example, solar and wind power, it's hard to always have access to it. So it has to be stored in batteries. And that isn't always the most efficient way to store energy. But with water, the energy is always there because the river is always flowing. So it's almost similar to having coal, the reliability of having coal and oil. Except for obviously there could be droughts that, like the one we're having, for example, in Manitoba right now, that will limit the amount of output a hydroelectrical dam will have. Manitoba Hydro has said about Manitoba that it's working on the issue, and that it doesn't think it will have any issues with delivering enough power to Manitoba this year. But droughts could be a big problem for hydroelectric dams, which rely on water. Now, another thing is there are very limited spots on the planet where you can put dams. Basically, you need a river, and rivers don't grow on trees, frankly. So there are very limited spots where you can actually put these dams. All right, moving on to issue number 2 before we run out of time here. We are going to be talking about fuel cells and hydrogen. Now, what is hydrogen? I'm sure we all know what hydrogen is, but just a quick refresher. It is a naturally occurring chemical element in a gaseous state. It comes with a symbol of H with an atomic number 1. And essentially, why it's important in this presentation is because fuel cells use hydrogen to generate electricity. Now, we're going to talk about fuel cells in just a bit, but just so you know the difference, hydrogen can be used to create electricity or energy in two different main ways, through combustion or through fuel cells. Now, both methods create water, but combustion creates heat and is hard to control and generally happens very rapidly. So if you want heat, burning hydrogen is a good way to go, but if you want electricity, you might want to put your hydrogen through a fuel cell because they are slower and it's easier to control and easier to efficiently generate electricity. I basically just explained what fuel cells are in the last slide, sorry about that. But I just want to reiterate, a fuel cell is an electrochemical cell that converts the chemical energy of a fuel and an oxidizing agent into electricity through a pair of redox reactions. So let's look at the redox reaction I'm talking about. Over here we have hydrogen being combined with oxygen, which essentially it's easier to to explain on the next slide, but here is the redox reaction in case you're interested. By combining the hydrogen and the oxygen, you release energy and water. So the chemistry behind the fuel cell is this diagram I have over here, where a hydrogen passes through a catalyst, and that essentially splits it into a proton, so an H+, and electrons, which pass through your electrical circuit, so they do the work for you, and then they return back into our fuel cell, and they combine with the hydrogen protons that are passing through the fuel cell, and they combine and basically create with oxygen from the outside and create water. And your electricity is being generated as the hydrogen runs through the fuel cell. Right? That is all the time I have to talk to you. So I hope you learned something, and I hope it was informative. And yeah, thank you so much for watching this presentation.